Good morning, students. Welcome back to chemistry class. Today we are going to study about chemical properties of hydrogen. In last class we completed the physical properties of hydrogen. Today we are going to study about chemical properties of hydrogen. What are the chemical properties? Chemical properties means chemical reactions of hydrogen with other elements. Okay. First property, reaction with oxygen. Reaction with oxygen. When hydrogen reacts with oxygen, hydrogen H2, what is the formula for hydrogen? Hydrogen molecule means H2. Hydrogen reacts with oxygen, formula O2. Oxygen molecule, hydrogen and oxygen, both two molecules are diatomic molecules. What do you mean by diatomic? Diatomic means the atomicity of hydrogen is 2. Like that, atomicity of oxygen is 2. That is called the diatomic molecules. Okay. When hydrogen combines with oxygen to form water, H2O. What is the formula for water? H2O. Okay. So hydrogen, when hydrogen combines with oxygen to form water, H2O. Okay. We have to balance the equation here. Hydrogen here 2 atoms or hydrogen here also 2 atom. Okay, but oxygen here 2, but here only 1 oxygen, so we can make here 2. Okay, now oxygen is balanced, but hydrogen here 2 2s are 4 hydrogens are having, so we have to make here 2 2s are 4. Equation is balanced. Okay, so in this reaction is an explosive reaction. Explosive reaction. Okay, and it releases a lot of energy. It releases a lot of energy. Okay, so when hydrogen combines with oxygen to form water, it is the explosive reaction. And when the forming water molecule, when combines with the hydrogen oxygen to form water molecule, it releases a lot of energy. That's why this is used in fuel cell to generate electricity. The hydrogen oxygen cell, it is one of the fuel cell. Okay, fuel cell. It is to generate the electricity. Understood? This is the reaction with oxygen. Then reaction with halogens. When hydrogen reacts with halogen to give corresponding halides. Okay, hydrogen reacts with halogen to form the corresponding halides. Okay, here hydrogen H2 plus halogen, I am taking X2. Okay, X2 means halogen. It indicates the halogen. What are the halogens are having? Fluorine. X means fluorine, chlorine, bromine, iodine. It is the halogen. Okay, when hydrogen combines with halogen to form hydrogen halide, HX, hydrogen halide. Okay, for example, when hydrogen combines with fluorine to form hydrogen fluoride, like that. When hydrogen combines with chlorine to form hydrogen chloride. Okay, when hydrogen combines with bromine to form hydrogen bromide. Okay, this is the reaction with halogen. When hydrogen combines with halogen to form hydrogen halide. Okay, here we have to balance the equation. Hydrogen 2 and halogen also 2, so we have to make here 2. Now equation is balanced. Okay, so the hydrogen, this reaction with fluorine, when hydrogen combines with fluorine, it takes place even in dark. Okay, dark place. the hydrogen with the fluorine reaction takes place. Okay, but the chlorine hydrogen when react with chlorine, this reaction takes place under the light. Okay, this reaction takes place under light. Okay, when hydrogen combines with bromine, the reaction with bromine means on heating the reaction is takes place. Okay, but iodine, when hydrogen combines with iodine, it is one of the photochemical reaction. What do you mean by photochemical reaction? Photo means light. Okay, when we are applying the light, sunlight, okay, sunlight, the reaction is takes place. Understood? These are the reaction with halogen. Reaction with halogen. Understood? So the hydrogen reacts with halogen to form corresponding halides. Okay, here this reaction, the hydrogen has an oxidation state +1. What is the oxidation state of hydrogen? +1. What do you mean by oxidation state? Oxidation state means, already we studied about that. Oxidation state, valence. What do you mean by valence? What do you mean by oxidation state? In our third unit, we studied clearly about the valence. So, what do you mean by valence? Valence means valence is equal to the total number of electrons in the valence shell are equal to 8 minus the number of valence electrons. This is called the valence or oxidation state. But oxidation state, it indicates the plus or minus symbol. Okay, because when losing the electron means plus oxidation state. When gaining electron means minus oxidation state minus. Okay, so valence means the electron present in the outermost orbit, or 8 minus the valence electron. Okay, so we are taking hydrogen atomic number we know 1. So when hydrogen combines with fluorine, I am taking one of the example. Hydrogen combines with fluorine. Here hydrogen, this is the nucleus and this is the proton, this is the electron, only one electron. Fluorine, what is the atomic number for fluorine? 9. Okay, first is, this is the nucleus, the first shell 2 electrons, second shell 7 electron. Okay, the fluorine need one more electron to get the stable configuration. Okay, the fluorine need 1 electron to get the stable configuration. So when hydrogen combines with fluorine, here hydrogen give this 1 electron to this fluorine atom. Okay, give this loss. Hydrogen can lose this 1 electron to fluorine atom. So what is the oxidation state of hydrogen for this reaction? +1. Okay, because the hydrogen lost 1 electron. Okay, when it gain 1 electron, what is the oxidation state of hydrogen? -1. Here for this reaction, what is the oxidation state of hydrogen? -1. Sorry, +1. Okay, so the reaction with halides, when hydrogen combines with halogens, halogen means fluorine, chlorine, bromine, iodine. Okay, when hydrogen combines with halogens, what is the oxidation state of hydrogen? +1, because it lost 1 electron to the halogens. Okay, understood? Okay, this is the reaction with halogens. Then hydrogen reaction with alkali metals. Hydrogen's reaction with alkali metals. Okay, what do you mean by alkali metals? Alkali metals, first group elements are called as alkali metals. Already we know lithium, sodium, potassium, rubidium, cesium, francium. These are called the alkali metals. Okay, so here when hydrogen combines with lithium to form lithium hydride, hydrides of lithium. Okay, so lithium means Li, lithium. It combines with hydrogen H2, lithium Li. This is one of the alkali metal. It combines with hydrogen to form lithium hydride, LiH. Okay, we have to balance the equation here. Hydrogen here 2 atoms having, but here only 1 hydrogen. So we have to make here 2. Okay, so but here lithium here 2, but here only 1 lithium, so we have to make here 2. Okay, like that. Sodium, another one alkali metal, when it combines with hydrogen to form sodium hydride. Sodium hydrogen to form sodium hydride. Okay, when balancing the equation here, hydrogen 2, but here only one hydrogen, so we have to make here 2. Sodium here only 1, but here 2, so we have to make here 2. Okay, so when hydrogen combines with alkali metals to form hydrides of alkali metals. Okay, but here what is the oxidized state of hydrogen here? -1. Okay, but when hydrogen combines with halogens, the oxidation state of hydrogen +1. Okay, because hydrogen atom lost its one electron to the halogens. But here, when lithium combines with alkali metals, it gains one electron from alkali metals. So, oxidation state of hydrogen -1. Okay, for example, I am taking lithium. What is the atomic number for lithium? 3. So, this is the lithium atom nucleus. This is the first shell. First shell, how much? 2 electron. Second shell, 1 electron. Because atomic number 3, 3 electrons are having. Okay. So, lithium atom try to lose this 1 electron to the hydrogen atom. Hydrogen, this is the nucleus, first shell, only 1 electron having the hydrogen atom. So hydrogen atom gain 1 electron from lithium atom. Okay, so lithium atom lost 1 electron to hydrogen atom and get the stable configuration, stable helium configuration. Okay, understood? So here, when hydrogen atom here gain 1 electron from the lithium atom. So here what is the oxidation state of hydrogen here? -1. Okay, minus indicates the extra electron. Okay, when losing electron means the element becomes positive. Okay, when gaining electron, the elements becomes negative, H minus. Okay, H minus. Okay, when combines with the halogens, hydrogen become H plus ion. When combines with alkali metals, hydrogen becomes H minus, hydride ion. Understood? So here, when lithium atom combines with the alkali metal to form hydrides of alkali metals are formed. These hydrides are used as reducing agent. Very, very important. These hydrides, lithium hydride, sodium hydride, these hydrides are used as the reducing agent. What do you mean by reducing agent? Reducing agent can lose an electron to the recipient. Okay, so thus it oxidizes when it loses electron in the redox reaction. Okay, the reducing agent means it can lose electron to the electron recipient atom. Okay, that element we call as the reducing agent. Element or compound we call as the reducing agent. Here lithium hydride and sodium hydride can lose electron to the other compounds or other elements, so it called as the reducing agent. Okay, so this is to prepare the lithium hydride used to prepare lithium aluminum hydride, and sodium hydride used to prepare sodium borohydride. Lithium hydride used to prepare lithium aluminum hydride. Similarly, sodium hydride used to prepare sodium borohydride. Okay, so here lithium hydride, LiH, lithium hydride, when it combines with the aluminium chloride, aluminium trichloride to form lithium aluminium hydride, lithium LiAlH4, lithium aluminium hydride. Okay, so and what is the byproduct here? Here lithium, only one lithium, here also only one lithium, aluminium here one, here also one aluminium, but hydrogen here 4, but here only one hydrogen. So we have to make here 4 hydrogen. Okay, 4 hydrogen. So 4 lithium hydride we are taking here. From that, 1 lithium forms the lithium aluminium hydride. Remaining 3 lithium atom having these 3 lithium atom combines the 3 chlorine atom to form lithium chloride. How many molecules? 3 molecules. Okay, from the 4 molecules of lithium hydride, 1 lithium atom combines with the hydrogen and aluminum to form lithium aluminum hydride, and the remaining 3 lithium atom combines with the 3 chlorine atom from the aluminum trichloride to form 3 lithium chloride. This is the byproduct. Okay, so the lithium hydride used to prepare the lithium aluminum hydride. Like that, sodium hydride, when sodium hydride NaH, it also combines with the trimethyl borate. It combines with the trimethyl borate, BOCH3 thrice, trimethyl borate, trimethyl borate. Sodium hydride combines with the trimethyl borate to form sodium borohydride. Sodium borohydride. Okay, here sodium borohydride, Na sodium borohydride, BH4. Okay, sodium borohydride. Here how many hydrogen atom having? 4 hydrogen atom, but here only 1 hydrogen atom having. So we have to make here 4. So 4 sodium hydride combines with the trimethyl borate to form sodium borohydride. What is the remaining product here? Byproduct. So here sodium, only 1 sodium we taken here, only 1 sodium, but remaining 3 sodium atom having these 3 sodium atom combines with the 3 methoxy group. Okay, 3 methoxy group to form sodium methoxide. Sodium methoxide. What is the formula for sodium methoxide? How many methoxy group having here? 3 methoxy group. So 3CH3O group. 3CH3O. And how many sodium atom remaining here? 3 sodium atom. Na. Okay, 3 sodium. Okay, understood? So when sodium hydride combines with trimethyl borate to form sodium borohydride. Sodium borohydride. What is the byproduct here? Sodium methoxide. Sodium methoxide. How many molecules? 3 molecules. Understood? Okay. And another one reaction also having here. Hydrogen also acts as the reducing agent. Hydrogen also acts as the reducing agent in the presence of finely divided nickel. It adds to the unsaturated organic compounds to form saturated compounds. Okay, when the hydrogen with nickel, it is acts as the reducing agent. Okay, it is used to reduce the unsaturated compound to Saturated compound. Okay, it is used to reduce the unsaturated compound to saturated compound. Okay, so what do you mean by unsaturated compound? Unsaturated means, what do you mean by unsaturated? What do you mean by saturated here? Unsaturated means when a compound having double or triple bond. When a compound having the double bond or triple bond, that is called the unsaturated. Okay, when a compound having multiple bond, that is the unsaturated compound. Here, acetylene, I am taking one of the unsaturated compound, that is acetylene. What is the formula for acetylene? CH triple bond CH. CH triple bond CH. Okay, so acetylene, when it reduced with nickel plus hydrogen, nickel finally divided nickel and hydrogen to form ethylene. What is the formula for ethylene? CH2 double bond CH2. Okay, CH2 double bond CH2. Okay, so which reaction takes place here? These two hydrogen atom added with these two hydrogen atom add here with the acetylene to form CH2, and one of the triple bond, it is break into double bond. Okay, so one bond having two electron, we know one electron it comes with this hydrogen atom, and another electron that goes to this hydrogen atom. Okay, so when acetylene reduced with nickel with hydrogen to form ethylene means CH2 double bond CH2. Understood? So here further they reduced with nickel with hydrogen to form ethyl. Okay, what is the formula for ethyl? CH3. Okay, C2H6, ethane. Okay, not ethyl, ethane. Okay, when acetylene reduced with nickel with hydrogen to form ethylene. Okay, acetylene, otherwise we call as ethane means a triple bond. When triple bond having, we call as we end with Y and E. Okay, two carbon atom means ethyl. So here a triple bond having, so we called as ethane. Okay, ethane, and it when it combines with reduced with hydrogen to form ethylene. ethylene. Okay, so when double bond having in a compound, it ends with ene. Okay, and further it reduced with nickel plus hydrogen to form ethane. Okay, so double bond it converted to single bond. Okay, one of the bond having two electron, these two electron goes to the one electron goes to this hydrogen atom, and another one electron goes to this hydrogen atom. Okay, so it form ethane. So the hydrogen atom used as one of the very important reducing agent. So we can convert it to unsaturated organic compound to saturated organic compound. This is unsaturated organic compound. It can convert it to saturated organic compound by using the nickel with hydrogen. Understood? Okay, then chemical properties of deuterium. What are the chemical properties of deuterium? Okay, like hydrogen, deuterium also reacts with oxygen to form deuterium oxide called heavy water. We know the hydrogen, when hydrogen atom combines with the oxygen to form water molecule. We studied already. Like that, when deuterium means D2. Okay, we know the hydrogen atom, that is the hydrogen atom having the isotopes. What are the isotopes of hydrogen? Hydrogen, protium, deuterium and tritium. Okay, protium, deuterium and tritium. So here we are studying now we are studying about the deuterium atom. Okay, deuterium, one of the isotope of hydrogen. Okay, so here hydrogen, about hydrogen we clearly studied what are the physical properties, chemical properties. Now we are going to study about the properties, the chemical properties of deuterium. Okay, like hydrogen atom, deuterium also combines with oxygen to form deuterium oxide. Deuterium D2, it combines with oxygen to form deuterium oxide, D2O, deuterium oxide. We otherwise we call this is the heavy water. This is one of the heavy water. Okay, normal water H2O we call this the normal ordinary water. D2O we call this the heavy water. Okay, by balancing the chemical, this equation D2 here, deuterium 2 atoms here also 2 atoms having, but here oxygen 2, but here only 1 oxygen, so we have to make here 2. But deuterium here form 4 deuterium atoms, so we have to make here 2. Now equation is balanced. Okay, like that deuterium also combines with, like hydrogen atom, deuterium also combines with halogens to form deuterium halides. Okay, D2 it combines with halogens, that is X2. Okay, it represents X represents the halogens. What are the halogens? X is equal to fluorine, chlorine, bromine, iodine. These are about the halogen. Okay, when deuterium atom combines with the halogens to form deuterium halide, DX. Okay, this is the chemical properties of deuterium. And another one chemical property also having deuterium. What is the chemical property? Deuterium, it is also exchange reaction. Deuterium exchange reaction. Exchange means, you know, exchange one element exchange with the other element. That is called a exchange. Okay, one element exchange with other element. Okay, so here deuterium can replace the hydrogen atom. Deuterium atom can replace hydrogen atom from that compound, from its compound. Okay, for example, I am taking methane. Methane, what is the formula for methane? CH4. Methane, what is the formula for methane? CH4. CH4 means methane. Okay, when methane combines with deuterium, the deuterium atom can completely replace the hydrogen atom from the methane. Okay, so to form CD4 and it liberates the hydrogen gas H2. Understood? So when methane, deuterium, what is the important chemical property of deuterium? Deuterium atom can replace the hydrogen from its compound. Okay, for example, methane, CH4, it is one of the compound of hydrocarbon compound. When it combines with the deuterium means D2, so D2 can exchange the hydrogen. Okay, so to form CD4 and it release the hydrogen gas. Okay, so here we have to balance this equation. Carbon, here only one carbon, here also only one carbon, but here hydrogen 4 hydrogen, but here only 2 hydrogen, so we have to make here 2, so 2 2s are 4. But D here 2 deuterium, here 2 atoms, but here 4 atoms of deuterium having, so we have to make here 2, so 2 2s are 4 deuterium. Equation is balanced. Similarly, it also can exchange the hydrogen from ammonia. Ammonia, what is the formula for ammonia? NH3. What is the formula for ammonia? NH3. When it combines with the deuterium atom can completely exchange the hydrogen from ammonia molecule to form ND3. Okay, ND3. we know D means deuterium. It is one of the other form of hydrogen. Another one isotope of hydrogen. Okay. So also it release the hydrogen gas H2. We have to balance the equation here. Nitrogen only one nitrogen, here also only one nitrogen, but hydrogen only three hydrogen atom having here, but here only two hydrogen atom having. So we have to make here here we have to make 3, then only balance the equation. So 3 2s are 6 here, but here 3 hydrogen atom, so we have to make here 2. So 2 3s are 6. Okay, also nitrogen here 2, but here only 1, so we have to make here 2. Okay, nitrogen also balanced now. 2 nitrogen, here also 2 nitrogen. Hydrogen 2 3s are 6, here also 3 2s are 6. Okay, but deuterium here only 2 deuterium atom, but here 3 2s are 6 deuterium atom having, so I have to make here 3. Okay, now 3 2s are 6. Deuterium is also balanced. Okay, these are about the chemical properties of deuterium. What are the chemical properties? First one, when deuterium combines with oxygen to form deuterium oxide, we call this the heavy water. Deuterium oxide D2O, we call this heavy water. When deuterium combines with halogens to form deuterium halide. Another one important chemical property, deuterium can exchange the hydrogen from each compound. Okay, students, then we are going to study about properties of tritium. Okay, we know tritium, it is one of the radioactive element. Okay, we know the 3 isotopes are hydrogen, protium, deuterium and tritium. Among the 3 isotopes, tritium, one of the radioactive element. What do you mean by radioactive element? Radioactive element means it always emits the electron in the form of radiation. It always emits the electrons in the form of radiation. That is called the radioactive element. Here, tritium is one of the beta emitter, and this is the half-life period of tritium, that is 12.3 years. Half-life period of tritium is 12.3 years. What do you mean by half-life period? Half-life period means the amount of time it takes to disintegrate by of an initial amount. Okay, amount of time to take the disintegrate or decay by half of its initial amount. Okay, half of its initial amount, that is called the half-life period. Here tritium atom take the time to disintegrate the half of its initial amount, that is 12.3 years. 12.3 years. Okay, by emitting the electrons, beta rays and electrons. Okay, understood? So tritium, we know what is the atomic number for tritium. Tritium atomic number 1. We know this is one of the isotopic form of hydrogen. Hydrogen atomic number 1. So tritium also atomic number 1. But what is the mass number? Atomic mass here, tritium 3. Okay, so when comparing hydrogen, the tritium atom has 2 neutrons extra. Okay, so how will you form the isotope? Isotope forms by increasing the neutron, by changing the number of neutrons. Okay, protons, number of proton, number of electron does not change, but number of neutrons will be changed. So it forms the isotopes. So here when comparing hydrogen, here for tritium atom 2 neutrons extra having. Okay, so the tritium atom one of the radioactive elements, so it always emits the electron. Electron is, what is the mass of the electron? Very very small, so it is negligible. So mass of the electron 0 and the charge is -1. Okay, the electron charge, what is the charge of electron? -1. Okay, so here tritium, it can be changed when it emits the electron, it can be changed into beta particle. Okay, beta particle means helium atomic number 2 and mass number 3. Okay, it is called the beta emitter, beta ray. This is called beta ray. Okay, beta, helium, atomic number 2 and mass number 3. How atomic number 2 here? We have to balance the electrons, number of electrons and number of neutrons. Okay, we have to balance the atomic number and mass number here because this is a nuclear chemistry. Okay, so here atomic number for tritium atomic number 1, but here helium atomic number 2, helium one of the beta ray, atomic number 2, mass number 3. How the atomic number 2 here? When it emits the beta ray when subtract the one electron, the electron, one electron from the beta ray, we get the 1. Okay, 1 electron. When 1 electron, subtracting this 1 electron from the helium 2, we get the 1. Okay, so we are now balanced the number of electrons. Here number of mass number here also same. Tritium at mass number 3, helium here also 3. Okay, so it is balanced now. This is the properties of tritium. Okay, tritium we know it is one of the radioactive element. It always emits the electron, emits the radiation in the form of electrons, and it always emits the beta ray. Okay, beta emitter. So what is the half-life period of tritium? 12.3 years. 12.3 years. Okay, so T13 it gives helium 2 3. Okay, atomic number 2, mass number 3. So it is called beta ray. Beta alpha particles means helium 2 4. Okay, when mass number 4 means that is alpha particle, this is the beta particle, beta ray. Okay, and the 1 electron means the also 1 electron. Okay, this is the properties of tritium, very important. Okay students, today our assignment, explain the exchange reactions of deuterium. Explain the exchange reactions of deuterium. Assignment number 1. Number 2, explain the properties of tritium. Explain the properties of tritium. Okay, students, now take your book now, page number 105. Explain the exchange reactions of deuterium. Page number 105, second paragraph. Deuterium exchange reaction. Deuterium can replace the reversibly hydrogen in compounds either partially or completely depending upon the reaction condition. Okay, these reactions occur in the presence of deuterium or heavy water. CH4 methane plus 2D2 gives CD4. Okay, so the deuterium, it exchanges the hydrogen from the methane. So it forms CD4 and hydrogen gas. Okay, another one equation, ammonia NH3, ammonia 2 NH3 plus 3D2. It is deuterium. It exchanges the hydrogen from the ammonia to form ND3. Okay, instead of 3 hydrogen, 3 deuterium atoms are takes place here. Okay, and hydrogen atom also release. Okay, and second question, explain the properties of tritium. Properties of tritium, it is a beta emitter with a half-life periods of 12.3 years. So tritium T13 to form helium 2 3 and 2 electron minus 1 0. Okay, all of you should study and write the assignment. Thank you all of you. Thank you.